Hey everybody, welcome to this tutorial. This tutorial is about a simple personal library application and is going to teach you some of the few things in bash scripting and GNU Linux commands. We start by writing the menu. I make a new directory in my home and then I cd into that directory. Bang $ means the last option of the command is issued. In this case, source. First of all, I copy the list of books from my home to here. I have a list of books that are separated by colons. Columns are title, author, publisher, year, and category. Alright, let's get started with the menu script. You can use any text editor of your choice. Vim is the one that we use in this tutorial. For getting syntax highlighting and line numbering, I add these two lines to the vimrc file in my home directory. From now on, each time I open Vim, these commands are going to be read by Vim. I also like to have a tab width of 3 characters. Now open the file with the Vim editor. Press I to get into insert mode. This shebang line should be the very first line of our script. It is an interpreter directive and simply tells that this script should be run by the bash shell. For showing the menu, I use a loop. This menu will be shown using an infinite loop until the user enters Q for quit. For the loop condition, I use the true command. True is a handy program that just returns exit code of 0 showing that the program ran successfully. I put printing the menu in a function and just call that function here. Each line changes the position of the cursor on the screen and echoes a line. The last line on the menu is prompting the user using read command. The read command gets user's input and stores it into a shell variable and has a useful option, -p. We can use it to show a prompt to the user. Case checks for values in the variable choice. If user writes A, add.sh script will be run. The // part makes sure it is running from current directory, not somewhere from within the path variable. We also run a script for printing a sorted list, finding a book, and removing a book. In the case of quit, we just clear the screen and immediately exit. For anything other than expected letters, it continues the while loop. Control goes to the beginning of the loop and menu will be printed again. The part for view is empty now and I will talk about it in a bit. Notice that when the execution of a script such as add.sh is done, Control reaches the end of the case and immediately reaches the end of the loop. Since this is an infinite loop, the next iteration of it will begin. Alright, let's test our code. I hit the escape key to get to command mode and then I type :WQ to write the file to the disk and then quit the program. I type the name of my script following the // which tells shell to run that from our current directory because otherwise shell tries to find a program with that name from the path environment variable. This error says I don't have execution permission on the file. Using chmod, I give the X permission to everyone on this file. I type a part of the name and press the tab key. Shell auto-completes the name for me. And here we have our menu. Now, let's write the code for viewing books. Open the file again. I write bang vi and then press enter. Using this syntax, shell tries to find and run the last command I ran, which began with vi. It will then find vimmenu.sh and then execute it. When the user wants to view all of the books, we use the less command to show the contents. Before that, let's see how it looks like. I open another tab in my terminal using Ctrl-Shift-T. My working directory is still the same as the previous tab. Less shows me the contents of the file, but I don't want the user to see those colons that I use for separating the fields. Now using the tr command, I can translate all of the colons to a single space. Tr reads from standard input and writes to standard output. I redirect the books file to standard input using the redirect operator, or less than operator, and pipe its output to the less command. Press Q to quit less and get to the first tab. I use Shift and the left arrow key in KDE, but those of you who use GNOME can use Alt and 1. It is a good practice to not hardcode things like file names all over your code, and instead make use of variables. And that is pretty much all about our menu. Let's write find.sh script. Make sure you have the shebang at the top of each bash script. After prompting the user for title, I put an empty line using echo. Let's see how we find a book. I go to the other tab. Using the grep command, I find the line containing the shell keyword in the books file. Notice that the case matters here. Now, I want to separate fields using comma and space rather than colon, so I am piping the output into sed command. Sed and then S for substitute colon with comma space, and globally, which means replace all of the colons and not just the first one. Since I have a space in my command, I have to enclose the whole expression in quotation marks. I put variable names for grep command into my script. If we run this, the user will see nothing because after writing information on the screen, the script ends and control goes back to the main menu. By adding a prompt at the end, the user has time to see the information. Read can be used without any variable name, and that means the user's input will be discarded. Sortprint.sh file prompts the user for a field to be used for sorting. Sorting the books is going to be done in two functions from the .sortfuncs file. We import these two functions using the source command into the script. First, let's write these methods. I go to the other tab and open the editor. Both functions use sort commands to sort the file on different keys or fields. Notice that the book file variable is not set in this file, but in the sortprint.sh file. In command mode, I put :w space .sortfuncs to write to the sortfuncs file. Let's get back to the sortprint script. After the prompt, we check for the user's answer, and based on user's input, we assign one of the function names to sortfunc variable. Why? Well, we will see that later. To make our output pretty, we print headers for the table we are going to print. Now it's time to sort and print information. I use the awk command for this. Pipe the contents of books into awk and then format the input using printf function of awk. Using the -f argument, we can specify the separator character. Now we can access each field using numbers. A %s is a placeholder for a string and corresponds to $1, which means the first field, title. Before running this, I just add a new line character to the end of each title. Perfect. I go one step further and add the second field, author. We can left align placeholders by writing dash and the width between % and s. This way, it looks better. Back to our script. I write the complete version of printf function. What is going to be passed to awk is output from either sort_title or sort_year. One of them is going to be replaced here based on the user's choice and then be executed. Everything looks good, but we have missed something. We don't have any of those functions loaded into the script. The source command can load that file from current directory into our script so we can use them on this following line. Source actually also has a synonym, which is just a single dot. Alright, let's test the script. Adding new book is implemented in add.sh script. This script first prints the menu and prompts the user for each one of those fields. Since we sort our data using title and year fields, we want to make sure a user does not leave those two fields empty. Test command has many useful options. One of them is -z that checks a string for being empty or white space. Another way to do this is using brackets, and that would just be a synonym for the test command. -o is just like the logical OR that evaluates expressions. Using these two options, we make sure both title and year fields don't remain empty. Make sure you put quotes around both variables because they may contain spaces. If one of these were empty, the user will see an error message. Otherwise, all variables are put together in order and added to the books file. Make sure you use two greater than signs, which means appending that line to the end of the file. Using one greater than sign overwrites the existing file. The last piece of our program is the remove.sh file. It removes a file based on the title. Before removing any record, we have to know how many records match that title. The grep command has a -c option, which changes the output to only one number representing the count of found records. This number is always 0 or more. Using the backticks around this command, we assign the output of the command, which is going to be a number to the count variable. Then in an if-else, we check for the value of count. The -eq option of the test command evaluates both sides for equality. If count is not 0, then it is more than that. Sed command comes in use again. Sed finds all the lines containing that title and then deletes them. This is not going to be deleted from the file yet because sed just sends the result to standard output. It can be redirected to a file. For the part of deleting the records, we also could use the grep with -v, which is the invert match option. This option writes the non-matching lines, which is what we want. I comment this line since we already have the sed to do it. Then we can copy that temporary file that has records removed from it to the actual books file. We remove the temp file and acknowledge users how many records were deleted. The last thing I want to talk about is a trap command. Now imagine the script is running and for some reason, such as the user pressing Ctrl and C on the command line, the script receives a signal. Now imagine the script is running and for some reason, such as a user pressing Ctrl and C on the command line, the script receives a signal such as a termination signal. Trap runs a set of commands on the occurrence of a specified event. Before getting to the if-else statements, I use a trap to execute some statements on the event of receiving signals for interruption from keyboard, termination signal, and closing of the terminal. For learning more about signals in GNU Linux, type the command man7signal to see the manual page for that. So what should happen in those cases? Well, I want to make sure that I remove the temporary file and then end the execution. Since I have two of the commands on the same line, I can separate them using a semicolon. I use -f to force delete the file and make sure it doesn't ask interactively. Also, for the purpose of this tutorial, I want to redirect the rm command standard error to the special place of nowhere, dev null. Everything you send to dev null is discarded. So this concludes our tutorial, and we hope that this tutorial helps you with some of the concepts around GNU Linux and Bash scripting.